Okay, so here's the problem. Now this sliding ladder problem is a classic calculus problem. It's kind of annoying because how often do you guys really care about a ladder sliding down a wall? I don't know.
I don't know, it's kind of fun to think about.
Yeah, I don't know. Okay, but anyways, the context really helps us by drawing a picture. So we have a 5-meter ladder that leans against the wall. So let's draw a picture of that. We have a wall right here. Here's my ladder. It is 5 meters. Okay? So there's my ladder leaning against the wall. Okay. The bottom of the ladder is 1.5 meters from the wall. Okay, so it's 1.5 right here. From here to here. Meters. At time t equals 0. Now, if I was a noob at this, I'd be like, t equals 0. I'm not quite sure what that means. But I'm going to write it down because it's a number, so it means it's probably important. Okay, the ladder slides away from the wall at a rate of 0.8 meters per second. Okay, so that's pretty important because it says rate, and I know something about rates. Okay, it's sliding this way, 0.8 meters per second. Okay, that's what this is. So it's going this way, 0.8 meters per second. So, hey, don't try to trick me. So, what did I do so far? I drew a picture, and I'm making sense of this problem, okay? That's it. Find the velocity, which is the same as rate. I don't know why they changed words right here. So, find the velocity of the top of the ladder at time t equals 1. So, this point of the ladder actually moves faster than this point of the ladder. Because as you move this out like this, because this has a greater distance to travel, this point right here will move faster to the ground, right? So the velocity that which this point is moving out, which is 0.8 meters per second, is not going to equal the velocity of this dropping. Okay? All right, so our job here is to find all the variables and write an equation that relates all those variables together. I know, so it's kind of weird. So, Marissa, okay, so here we go. First, let's look at point 8. How else can we write point 8? Now we have to go back to like your understanding of derivatives, because when you guys take a derivative, that gives you a rate, right? So, how else can I write this right here? We can write that as, I'm going to write dx over dt. Now, why is it dx over dt? Guys, we're talking about rates. We're talking about how fast this is moving out. Now, I'm using x because x goes horizontal. I'm using t because it's with respect to time. So, if this one is moving down, how would I describe that rate? You can say dy over dt, or it's also common to say dh over dt, because h would represent height. So we know this one. This one is 0.8 meters per second. This one we do not know. In fact, this is what the question asks. Find the velocity of the top of the ladder at time t. This is the velocity of the top of the ladder. So here we have a variable. Here, let's circle all our variables here. We have a variable right here. We have a variable right here. This is our variable. This is a variable. We're calling that one x. And actually, we should have a variable right there, too. Let's call that one y. This is y. Okay, so what's a function or an equation that would relate all these variables together? We have a triangle right here, right? So what's a triangle formula? Yes. No, that's the area of a triangle. Pythagorean theorem. So, we're going to have x squared plus y squared equals, we'll say c squared, yeah. Okay. So this equation relates all these variables, right? Well, how are we going to get these ones out of this? We're going to take the... Oh, you guys sound so excited about that. Okay, now this is kind of weird because, listen closely, we're taking a derivative with respect to time. So because we're taking the derivative with respect to time, it's kind of like we're implicitly deriving all of these guys. So when I derive this one, I'm going to have to say 2x, but then I have to multiply it by dx over dt. Okay, now I'm going to take the derivative of y squared. Now remember, it's with respect to t. So that means we're going to have to do what we did with the x. So it's going to be plus 2y times dy over dt. And then I do it with the last one, 2c times dc over dt. So we have two equations here. Here's the original one. Then we derived it. Now we have rates inside of our equation. Now what you have to do is plug in everything you know. Do we know what the x is? Do we know what dx over dt is? Do we know what y is? Okay, so all those values, do you know what they are? Can you plug them in? So let's get going with it. Do we know the x?
Can we use our
Now,
calculators?
you have, absolutely. You can use your calculators to help you out with this. But right now, oh yeah, you will for the Pythagorean theorem. What is x going to be? Now remember, we're at t equals 1. We're not at t equals 0. This is t equals 0. What's x going to be when t equals 1?
According to the rate.
Yeah, according to the rate, every second it increases by 0.8 meters.
Oh my god.
So, all right, here I got to draw another part of our picture here. So after 1 second, this slides out that way, right? So technically it's right there. And so this is really going to be like this, right? And so what's the distance between here and here? It's 2.3. We added 0.8 to it. So I'm going to say 2.3 meters. We added 0.8 to it because that's our rate. So now over here I'm going to put 2.3. And that's multiplying times, what's dx dt? Do we know what dx dt is? Oh yes, it is 0.8. So I'm going to put 0.8 right here. Plus, now do we know that y? Okay, that y is not there, but actually it's not what we're trying to find. We're trying to find dy over dt. We're trying to find this guy. So can we find the y?
Pythagorean theorem.
Yes, Pythagorean theorem. We're going to have to do the Pythagorean theorem with 2.3, 5, and this new y right here. Ooh, so let's, all the moans and groans, you can totally tell it's almost Friday.
And then you give us 1 through 12. You give us 12 times.
That's why I only said 1 through 12. Okay,
12 times.
let me set this up. Or y squared plus 2.3 squared equals 5 squared. So we use this to find the value of y. Quickly, does anybody know what 2.3 times 2.3 is?
4.9. Because we memorized that.
No, you guys have your calculators out. That's why I asked you. 4.6?
5.29.
So a minus 5.29. What is this subtracting? Like, what do you get right here? It's y squared equals, is it 19? No.
18. Wait.
No, it's 1971. Okay. Can you guys square root that? What do you get?
4.439.
4.439?
Yeah, 5 times 4 5.
Okay, I'm going to say it's 4.4. Okay? So, I can't move it up because I have to do work with this one. So I'm going to plug in the y as 4.44. Now we have dy over dt, which is what we're looking for. dy over dt, that's a one we don't know. And this is my favorite part. Okay, you guys see this right here? This says the rate at which the ladder is changing. Now, is the ladder changing its size? So what is this rate? It is 0. So that gets rid of this stuff. So this just equals 0. What's that? There's lots of thinking of all of this. That's true. But notice that's why I drew a picture first and identified my rates. Draw the picture first and identify your rates. Now what you have to do is algebra, guys. Multiply these together, move it over to the other side, and divide it by that. We should get a negative rate because it's going down. Can you guys multiply this together? Tell me what you get. So we get 3.68 for the first part, and then this would be 8.88 times dy over dt equals 0. So let's go ahead and move this guy to the other side. So now it's negative 3.68. Then I have to divide it by 8.88 to get my rate. So dy over dt would equal
Alexander Karimi Van
negative 0.41 meters per second. Okay. So just to recap what we just found, we found the rate at which the tip of this ladder is sliding down at this point right here, which is at t equals 1. Now the rate is negative because it's going down. Another reason why, or another thing to note is that this rate is smaller than the rate at which it's being pulled out. Keep this in mind, that this is only that rate at that moment. If we go to t equals 2 at 2 seconds, I don't know yet if it hits the ground yet, but we would find out. Like if you did 2 seconds, it would actually it won't hit the ground, because if I add another 0.8 there, it'd still be smaller than 5 meters. But the rate does change as it falls and as you're taking this out. So cool. Hope that helps.